it's not.
No, so
That's why differential equation.
So if you take the generic function to prove this holonomic, you should find the odd annihilator. And how you can find the odd annihilator in general? Because maybe you lose something, then you lose some information. Maybe dimension is bigger, then you conclude. You get a wrong conclusion.
Yeah.
So this is why to check properness is easier. You can do you can verify this algorithmically, but to compute the annihilating idea of a function, there are no.
No, in general I agree, but indirectly, if it would have been by contradiction, it would have been proper, they will follow from the fundamental theorem. They satisfy a differential equation in X with polynomial coefficients. I think you look at the analytic properties of this.
Yes, you can. Yes.
Yes,
there are another way.
Much better.
Yes. There's another way to. No. Your fundamental lemma is just for proper input.
Yeah, so prove a contradiction.
But this is not a proper input.
Yeah, so if it would have been proper, then the sum over n would have been a function with certain properties that can be shown not to have these properties. So for this specific two examples, you can have an indirect proof.
Yes.
That
You can also have indirect proof for this one.
Yes.
Yes, it was. But now we need this conjecture will give you the systematic way to verify this. Yes. Also, actually, your method is not just works for hypergeometric function. You can also works for some non-holonomic function, non-hypergeometric function. There are some very famous examples which are not holonomic. For instance, this is a gamma function. If you view this variable as a continuous variable, you can show that this gamma function satisfies no linear differential equation. Then this is not holonomic. And also there are some people can show that square root of n or log n are not holonomic if you view n as a discrete variable. So this is the five typical non-holonomic objects. So there is a famous sentence by Jian Lotta say, if you give a lecture, you should give your audience something to take home. So you can forget my previous slide, just remember this one. So now comes to my summary. So actually, you have already seen that in the discrete case, people use we call the Ore-Sato structure theorem, which is Ore-Sato is for the multivariate hypergeometric terms. It's just in the purely discrete case. And in order to prove this general Wilf-Zeilberger conjecture, we discover this structure theorem for the general hypergeometric functions. So let's repeat this sentence. So this structure theorem tells us any hypergeometric function can be written as product of a rational function, and power function, and exponential function, and some constant power, and some factorials. And all of those are very simple, like apple and banana and kiwi and something we are very familiar with. So this is, and now with this work, we turn Wilf-Zeilberger conjecture into a theorem. So now I can state this theorem now. So any hypergeometric function is holonomic if holonomic proper. So now it's a theorem. And the main the importance of this Wilf-Zeilberger conjecture is this is a bridge between the holonomic and proper. And now we know how to verify properness algorithmically. By this conjecture, we can also verify the holonomicity algorithmically. And as a personal inequality, also my personal religion, I always believe that conjecture is much more important than proof. So thanks, Dora, for this conjecture, because this conjecture not just give us this and also give us this big theorem. Okay, thank you for the.
Two questions. First, let me comment. This is inequality, but it's not. Could be bigger or equal to. And then I have
no.
It's not strictly equal to. It's my personal inequality. And then in this particular case, in general, you may be right. the Riemann hypothesis is probably more important than the ultimate proof, if and when it will exist.
Yeah.
Sometimes it's true. But in this particular case, the reverse inequality is also true. Proof is smaller or equal to the conjecture. The corollary, the proof, is at least as important.
Yeah. Can you give us something to take home by way of printed paper?
For what?
Can you give us something to take home printed?
You can download it.
Yes.
On its website.
Printed? Oh, it's on your website?
Yes, yes. But I haven't submitted this paper, so next month I will submit this one.
Yeah, it's beautiful.
So this is, we just finished the writing. Actually, we get this. But I have a paper on this structural theorem. So this is published. The structural theorem is published.
How many pages?
8 pages. But this is a fairly strange style of writing because 8 pages, but they have 2 columns. So in general, this is 16 pages, and the proof is very technical.
Yeah, this beautiful design was my dream to have it proven, so it feels very important. Any question?
So yeah, sorry if this is a very basic question. Maybe this is what you guys are talking about, but from what I know about this stuff is, so Zeilberger earlier showed that some certain sums like have no nice closed form, like the sum of the cubes of the binomial coefficient. So knowing this theorem, does this give a larger class of sums where we know there's no nice closed form? Is there anything along that? I'm curious about the motivation for studying the when holonomic is proper or not.
The motivation is also one of the key, because before you apply Wilf-Zeilberger's method, you should know whether your input is holonomic or not.
Okay.
Otherwise, you will not try this.
Okay.
So this conjecture will tell you whether the input. So before you run Wilf-Zeilberger's algorithm, you will see whether I will run his algorithm or not. Otherwise, there is no termination. So you will waste your time.
Okay.
This is why. Also, this give a very will tell you some information about the termination of this Zeilberger's algorithm. So you will know the termination a priori.
The fundamental theorem will stay in terms of properness, not holonomic.
Yeah, so this feels. Now you don't need the proper, that's the holonomic. So before it was a tennis condition. So this feels very important.
Well, I always intentionally ignore the holonomic.
Yeah.
Now you can ignore. Now you can, because they are equivalent. So now you can eliminate all holonomic. Yes.
So it's both theoretically important and also practically important.
Theoretically, this is also dream of Doran, because he don't want to use this holonomic, because very technical. You define this with a Hilbert dimension, and the proper very nice because this is very explicit. So this is also. But now this show you that everything holonomic is just a proper.
Thanks again.